fall of 2020, JuggerBot 3D had an opportunity to submit a proposal to the United States Army to develop new technology, new materials, and overall a new technique within the world of additive manufacturing. This technology has been called direct ink write, which allows people to process two-part thermoset materials like epoxies, polyurethanes, and silicones. JuggerBot 3D was awarded Phase 1, which for us was a 6-month project that was approximately $165,000. And in that project, the objective through the United States Army was to develop a new technique that would allow people to process thermally activated materials, which in a sense is a thermoset material. We had 6 months to develop this technology, develop these materials, additively produce test specimens, create a baseline for the materials and the process, and even develop functionally graded thermoset materials or functionally graded thermoset parts. And particularly, we were trying to demonstrate the ability to 3D print functionally graded parts, either thermosets with thermoplastics, thermosets with metals or other manufactured components, and even thermosets on top of thermosets. We decided to work closely with Penn Barron, which is in Erie, Pennsylvania, a known research institution to help us characterize new thermally activated, thermally cured thermoset materials.
The flagship program of Penn State University is materials, so that's all materials, but has a special emphasis on polymer systems and plastics. Particularly here at this campus, at Penn State Barron, there's a plastics program that's focused on conventional processing of plastic materials, commodity plastics that most people would be familiar with in their daily lives. That program has existed for almost 3 decades. And so there's a lot of resident expertise here in processing of polymeric materials, plastics in particular. Recently, over the last couple of years, a new program has emerged, actually in 2020, in polymer engineering and science. And the emphasis there is really on the material science of polymer systems. So now we have a faculty that goes across all of that spectrum, all the way from the fundamentals of polymer science, the chemistry, molecular structure, all the way up to product design and processing and evaluation.
Throughout the program, we partnered up closely with 2 material developers, Chromatic 3D Materials and also X-Link 3D Materials. Both these companies have developed new performance-grade thermoset materials specifically for additive manufacturing. Lastly, we decided to work closely with BDI Additive, a customer of JuggerBot 3D's, who has recently purchased this new technology and has been deemed the manufacturer of 3D printer for this particular project. So using our Tradesman series F332-H, BDI Additive was tasked to additively produce test specimens with these newly developed thermoset materials. The test specimens that they developed or they processed were just some simple geometries, test squares, cylinders, components that could be tested later down the road with Penn State Barron, and they can pull some interesting data for mechanical or thermal or rheological data.
We fully characterized the mechanical properties of the material. We got a really good understanding of the flow characteristics of the materials that we were testing. There were essentially 2 or 3 different materials, many different formulations, but 2 different material systems. So the next phase would be to take that data that we've already generated, supplement it with more data across a different range of deposition parameters, right? And then the real big task would be to develop a mathematical model that would allow JuggerBot 3D to develop the types of control schemes that they need to print up not only a geometry on demand, but a set of properties on demand. For instance, if a particular set of mechanical properties, say, are required on a particular component, we can embed the model that we develop in JuggerBot 3D's control software so that it'll be possible to predict exactly how the material prints, and then probably just as importantly, what physical or mechanical properties the component ends up with. That's the goal. That's kind of the holy grail for a phase 2. It was a 6-month program. It was pretty intensive. We produced an awful lot of results. But I'm pretty optimistic. We've collected the right kind of data.
Additive manufacturing is going to be hybrid manufacturing. The ability to process multiple materials or multiple manufacturing processes for one application. And so for us to be able to make direct ink writing a prominent technology similar to fused filament fabrication or fused granulate fabrication, to be able to control these materials and optimize them specifically for the application that can be used in the real world, we're going to have to take a next leap into optimizing the materials for the process and being able to create new unique technology and new unique software to control those said materials.